Right, well, I should be pretty good at this because I have just recorded this session, taking me whatever it takes me to do, and found out that at the end, when I looked at my other monitor, it stopped recording after 10 seconds. So fantastic waste of time there. Never mind, I'm not bitter at all with the equipment, and after this video, I will be throwing my PC out of the window. So I'm going to be doing testing today for the second time. So just a quick reminder of the advice. Please, please, please pause when asked to do so. Have your pen and paper ready and make sure you're jotting down these things and having a go. It's just not worth doing if you don't. Please do it. Okay, let's get in there. Objectives. So we're going to look at the purpose of testing today, which includes types of testing. It includes syntax and logic errors. And for the second time today, I've got a spelling mistake. You'd think I'd have fixed it, knowing that in the first video, I looked a fool for leaving it in there, and now I've left it there again. So hats off to me. Um, so we've got syntax with an X errors and logic errors to look at. And we've also got the types of tests that you might do. There's 4 of those. So we're going to whip through those. And there's some extension at the end, which you might want to look at as well. That's completely up to you. Um, in regards to the syllabus on the RAG map, just because the new version looks a bit more structured, it's actually still what's in the old version. So it doesn't matter which syllabus you're on, whether you're on the year 10, year 9 syllabus, it's the same kind of stuff. So let's have a look at why test. So you're writing the next big indie game. It's going to rival Minecraft. And if it does, by the way, just remember who your teacher was and throw a few million my way. That'd be fantastic. Um, and what I want you to do is, why would you test it? So just pause the video and write down a few reasons as to why you would test a piece of software. Many reasons you can come up. Pause now. Okay, so the most important reason to test is to check it does what it was meant to do. That is the most obvious thing. That's why you test it in the first place. If you went set out to do something, you would have had some requirements, some things that you would have thought, right, if I can do these things, I have been successful. Well, that's just checking that it's doing what it was meant to do. So that's the first thing you say. So you get asked that question, you say to check what it does what it's meant to do in an exam situation. And then the second thing is to find bugs and errors so that you can fix them in the code, because they're just going to cause problems. So there's your 2 reasons. Don't forget them. Make sure you know. Have a look at what you wrote. Hopefully, something similar. So when do you test? Well, there's 2 kinds of testing. You've got iterative and you've got final, or also called terminal testing. I want you to pause the video and have a guess what they are. You probably have an educated guess here, a little bit of a, if you look at the words that they use in there and you know what you know about iterative or iteration, see if you can figure out which is which. Pause the video, write down a couple of lines, and I'll tell you what the answer is. Okay, so iterative testing is you do it as you're developing the code. You test as you're developing the code. So you code a little bit, you test it, and then you move on. Whatever you've built, you move on and you keep building upon it. You build upon it. Now this is quite common. What you would do anyway when you're in a classroom or you're coding, because you do a bit, you check it's working. You do a bit, you check it's working. In the real world, this is very common. It's often called agile programming, or it's a method where you kind of keep building upon what you did and you keep testing, you keep evolving until you get to the product. So that's what iterative is. In example, you might just check the movement of your character works before you then code something else in a game. Final or terminal testing is testing that you do after the program has been finished. So you finish coding the whole program, and then what you're probably going to do is look at a set of planned tests that you would have written prior to even making the program as a set of tests that prove unequivocally it works. Now, if you think about in the real world, and you're asked or tasked by a big company, we need a piece of software that does A, B, C, and there's lots of stuff it needs to do. Well, you need to write a really detailed test plan to ensure that it does what you want it to do. And that would look something like this. This is just a couple of tests, but this could be quite rigorous. And it might be like, I'm going to check the WASD keys move the character around the screen. What's the input? I'll press WASD. What do you expect to happen? I expect the character to move around the screen. And what actually happened, so that last column would be only if you were running the test. So I've kind of made it up some results. So I put that worked. But then for pausing, where I press P, I expect the game to pause. Well, I've said it failed because the other sprites carried on moving when I paused my character. So that wouldn't be very good in a game. So I want you to pause the video and I want you to write maybe a couple of tests in that format without the actual column. You're not going to run them, just the other columns for maybe a couple of tests to do with a program either you've written in the past, or it could be just something made up, like if you were making a game, what kind of test. Don't do my tests because I know what you like, and I know you're going to just go, oh, press WASD. No, no, naughty. Do your own tests. All right. It's all right, my video's still recording. I keep checking. If you see my eyes suddenly go over this way, it's because I don't trust it anymore. Okay? I don't trust you. I don't trust you. So, kinds of error. Syntax spelt correctly this time. Thank you. Breaking the rules of the programming language. So, if you do something that is not expected by the programming language, so you go and hit in Python, you go save and run, which is F5. If you've done a spelling mistake in there somewhere or something really stupid, you've forgotten a colon or you've indented wrong, well, it's going to be detected by what's called the compiler. Now, we'll talk about compilers another time. For now, it's the bit that's going to detect that error. And the program's not going to run. It's going to go, excuse me, that's wrong. Probably not like that. If it's Python, it'll probably be in Hebrew or something that's equally as helpful to an English reader. But you know, you get used to them and it's meant to be helpful. It's just sometimes they're not, but it's going to give you an error. Logic errors are the program will run, it will look like it's working, but it's not detectable because you haven't really made a mistake syntactically. You haven't done a typo or missing something. It's just you've done something probably stupid or wrong, or like you put a greater than symbol instead of a less than, or you forgot to put an equals with a greater than, or it could be a lot of different reasons. You've done an addition or calculation wrong, which has led to a faulty result. So this could mean endless loops. It could mean just trapping the player in some kind of sequence. It's a logic error. So here I've got some errors. Courtesy of yours truly, I've written some errors for you. And I want you to, on your piece of paper, draw two like sections, one logical errors, one syntax errors, and I want you to put all the syntax errors, all the kind of stuff the computer would go, oi, that's wrong, in one section, and I want you to put the logical errors where the computer would say, hey, this is good, but it wouldn't work properly. So pause. This is a good one. Have a go at it. See how you do. Okay, so these are the reasons. So on the logical side, you see there print name. I put it in quotes. It's a little bit of a sneaky one. It would print name, not Bob, because with the quotes around it, it's going to write what's inside, isn't it? So I should have not had quotes. That was a logic error. It's a variable. And if you still don't get the difference between putting quotes around something and not, please go and look it up about variable use in Python. It's fundamentally important you know how to do that. So really go and have a look at it if you're still not sure about those. Second one, while a is not equal to 0, print a. Well, there's nothing there to make a smaller. So if it doesn't get to 0, you're in an endless loop. So I've added a line to take 1 away from a so that we can get down to 0. Presumably it's some kind of countdown. And then a sneaky one there, if a is greater than, I put 18. Well, it needs to be greater or equal to 18. Otherwise, 18-year-olds are going to be told they're children, which probably won't amuse them very much. Over on the other side, I missed the colons. You know what Python would do. It would go nuts if you did that. Primt, easy spelling error. And then I put a capital C instead of a little c, which means if you did that, it would go print. It wouldn't be able to do print C because it's wrong. In fact, thinking about it, that might be a logic error because I'm referring to a variable that doesn't exist. It might compile, Depends on how clever the compiler is. There's one for you. If you've got Python, quickly run that up, will you, and see if it compiles. If it compiles, it's probably a logic error. But I'm not sure. Sometimes Python's clever enough to know that you can't refer to something that's not been declared. So in that case, it would be a syntax error. Ooh, the fun of Python and coding. So types of test data. You need to know the kinds of tests that you can perform. So we have got normal tests, boundary tests, invalid tests, and erroneous tests. Here's a little challenge for you. Imagine you're doing a system that puts scores in 0 to 100%. They're percentage scores, so you know they're going to be between 0 and 100. Can you guess what values you would put in for each test to a normal test, a boundary test, an invalid test, and an erroneous test? Have a go. Pause it. What have you got to lose? Maybe a little bit of self pride, but who cares? It's going to be good fun. Pause, have a go. All right, welcome back. Here's our range 0 to 100. If we do anything between 1 and 99, valid test. See if that's what you had a guess at. If you did anything below 0 or above 100, so -2 or 101 or 3000, they're invalid. They're not in the range that you would expect it to work. If you do 0 or 100, that is the minimum and the maximum, the biggest and the smallest values you would expect it to accept. And in which case, they're boundary, or sometimes called extreme in some textbooks. They're the same. And finally, we've got erroneous. Now, you're probably thinking, well, wouldn't that have been the ones out of bounds? No, because it's still a number. If it's so ridiculous that it just doesn't belong, that would probably be erroneous. So I've put Bob. If you wrote Bob as a percentage, clearly that's going to cause some problems. So Bob. So a couple of extensions you can think about. Maybe go out and have a look on Google and see where lack of testing has probably led to seriously bad situations in the real world. There'll be a lot of examples, and you might be able to even think of one off the top of your head. And also, just a note, some good habits when you're coding. I'm hoping some of you have got Python on your systems by now, and if you have, when you're coding and doing little bits of self-guided learning on Python, start to get in a habit of testing more rigorously. Try and break your code and see if you can get underneath any errors, and then think how you would then code better to prevent the user breaking the system in that way. And also, there's something you can check out on BBC Bitesize. If you just Google syntax errors in practice, you will find it. And there's some stuff there. Craig and Dave videos, obviously, there's those as well. You can look at lots of stuff. So before you do the quiz, please make sure you're happy with all these things. Please make sure you do it. But don't just rush off if you're not happy with what you've done. There's quite a few definitions there. Do go through them, even if it means running the video without doing the participation, just to make sure that you're clear. I hope you've enjoyed the session. I enjoyed it first time round. I enjoyed it second time round as well. I think it's probably better the second time round, in truth. I can see it's still recording, so we should be all right. So take care, stay safe, stay indoors unless you're exercising, and enjoy yourselves. All the best.